right, this is our lesson 3 on inverses. I'm trying to make these a little smaller and a little shorter so you can kind of pick and choose what you need to go through. Before, just kind of review, I went through an example using a line, a simple one, and to illustrate what one-to-one is. And just a quick review is that we need to find it one-to-one function, because if you don't know the function is one-to-one, then the function doesn't have an inverse, or you might not be able to find it. So coming here is we're going to talk about different ways on how we can identify, all right, functions and their inverse, all right, and how you can identify if they're one-to-one. Okay, so identify functions and their inverses, and there are a bunch of different ways. Okay, now when you have this, okay, and the reality is that we're trying to identify if the functions are inverse to each other, and the function itself, is one-to-one, so we can find the inverse and so on and so forth. All right, so first off, if we have a function, and first off, I want to see if this is an inverse. This is a cubic function, and you can graph this. And actually, what I'm going to do is I'm going to take this and I'm going to graph it. I'm going to pause this while I get my graphing. All right, now my calculator is ready. Yeah, math or magic on this little tutorial on YouTube and videos. 1 second you saw no calculator, now you see a calculator in 3 seconds. Wow, magic. All right, but our goal is we want to figure out, all right, algebraically as an inverse. So I guess before we do that, I just want to make sure that it is one-to-one. So I'm just going to check to verify this is one-to-one. And this will help us out in our remaining parts of testing. All right, so I'm going to put in here x cubed, and I have minus 5. And I'm going to graph this. All right, I have a 10 by 10 window, and I have a basic cubic function that's been shifted down, all right, 5 spots. And so we have this. Now, looking at this, hopefully we can identify, all right, is this function one-to-one? So if we look at the horizontal and vertical line test, I'm going to take out my line. All right, obviously the vertical line test, horizontal line test, I go up and down. Yes, it is one-to-one. It passes both the horizontal and vertical line test. All right here, everywhere, looks good to me. All right, so get rid of my line. And so because it is one-to-one, 1, 2, 1, all right, one-to-one, what we can do now is we can find its inverse. Now, if you recall in the past tutorials, there's a 3-step process. We first need to write this out as y equals x cubed minus 5. Now we need to switch to x and y values. So now we switch and have x equals y cubed minus 5. And now we're going to solve for y. Okay? So now when we solve for y, I'm going to add 5 to the other side, do my algebra. And then we take the cube root. And we find out that we have for y, which equals this little notation right here, this is actually equal to y, it's going to have the cube root of x plus 5. All right. So what I want to do is here, I want to identify, all right, there are some similarities and differences between these two graphs. So what I'm going to go over here is now I'm going to take this, and I'm going to actually graph its inverse. And the graph is going to be in red. And I'm going to go right here. And I'm going to put in the cube, so I have x plus 5. And then you can raise that to the 1/3 power. I'm going to put it the 1/3 power. All right. I put parentheses. I don't have to if you have this kind of calculator, but if you don't, do caret, and then put in parentheses 1/3 power. And I graph that. And here comes my inverse. Slowly but surely, here it comes. All right. That's kind of a neat graph. And we have that. Now, look at this graph. I have this right here. All right. Is that you might see that there are some values here. So here's my inverse function. Here is my regular function, original function. And what do you notice about the symmetry between these two graphs? Well, what we have here is actually a function and its inverse, all right, actually are symmetrical over not an axis, but actually a line. And this line is y equals x. So there is symmetry over a y equals x line. That is true for all functional inverses. They are always symmetrical over the y equals x line. That's something you have to know and kind of memorize. All right? Even functions are, all right, have just one symmetry over the y-axis. Odd function has a symmetry of the origin. This is what we talked about before. All right, but inverses have symmetry. When you compare two graphs, the two graphs have symmetrical over the y equals x axis. Now, that is one test to see if a function and another function are inverse of each other. So graphically, there's symmetry. Another way to test it, and we've done this before, is we can compose the two functions together. So you take f composed of its inverse again, all right, and you're hoping to get the function, the value inside, which is equals x. So if I took, once again, f and compose that, so we have the cube root of x plus 5, and I cube it, and minus 5, and what you recall it was will equal x. They are inverse of each other when you simplify that. The other way, because there's symmetry over this y-axis, another thing that you might notice is that on a table, okay, if we took out our graph, our calculator right here, and you took a look at the table feature, okay, and we compare some values, okay, and I'm going to go a second calculate. We'll go over to our table right here, all right, and I'm going to look at some values. For example, all right, when I look at, for example, 0, this is one I'm going to look at, all right, -5 and 0 right there. All right, when I plug into the original value, oops, not right there, I apologize. Okay, this is my inverse function graph. This is my regular graph. Now, when I plug in the inverse, I notice I have -5, 0. When I look at the function, all right, 0, -5, what do you notice about the inputs and outputs of inverses? I input a -5, I get a 0 for the inverse. I input a 0, I get a -5 for the function. Well, what we have here is actually the values of function and inverse, everything is switched. All right? The values are the inverse points. Inverse points, if we have f of a equaling b, for an inverse, those points are switched. Okay? And what we have, because that has symmetry, because of the symmetry over the y equals x axis. We plug in b, we get a. So the inputs and outputs are switched. And we can see this right here. If you look at our domain of f of x, okay, the domain of f of x, which happens to be, all right, all real numbers, but if you look at the domain right here, okay, that is what to the inverse? Well, the domain, all right, is actually going to be the range of the inverse. And this is kind of a bad one because it is all reals, but it's going to be the range of the inverse because the values are switched. So the domain, the x values of the function, are actually the y values of its inverse. Right here, when we talk about the range of the function, the y values of the function are actually the domain or the x values of its inverse. Everything is going to be switched. Okay? Let's try another one just to kind of illustrate this point. All right? Oops, right here. All right, this one right here. Okay? This is a little bit different. So what we have right here is a function. Okay? A function of the square root. So if we take out our calculators, you want to look at this right here. And I'll get rid of these. Ooh, hello. Okay? I'll get rid of that right there. And we want to go to our y equals, and we'll punch those in there. Okay? So we can get a decent graph. It is this square root function. And we have a negative right up there. So I'll put a negative. And we have the square root of x minus 8. Now, when we graph this, we can see that, yes, it is 1 to 1. We don't see the full graph. I'm going to change my window. I'm going to go over to the left a little bit more. I'm going to go with 20. And we'll start right here at 5. All right, so I went to my window. I'm going to graph this. And I can see this graph right here. All right. Now, from here, okay, I have this. All right. Now, as we go about solving this, I want to find out its inverse. It is a, all right, function. All right. And then when I solve this, I have switched, I'm putting my x and y's in here. Now I switch my x and y's. And now I solve for x. Or solve for y. Solve for y. So I have the opposites. Got to take the negative first. Square root of y minus 8. Let me move this over here. Okay, and then I take and square both sides. So we have negative x, and I'm going to square it. Minus 8. And now I'm going to add this, and what we have is x squared, all right, plus 8, that equals y. All right, and actually, in actuality, this is my inverse function. Okay, we can test it out, all right, just to make sure. And I'm going to do that because I'm going to punch that into my calculator. So I'm going to go y equals, and I'm going to go over here and punch in x squared, all right, plus 8. Now, I'm going to go back to Zoom 6 and look at this and find out what this looks like. All right, and we have this. Now, in my window, I'm going to make this a little bit bigger. And I'm going to go up. I'm going to go to the right. We'll go 15, and we'll go down, or up, that is, 15 as well. Let me graph that. Okay. That's because I want to see a better graph. Now, when we see this, okay, hopefully you notice something. Our inverse function that we found is actually a parabola. It's actually a parabola. Let's make that in red. All right, so the red one is actually a parabola. Well, how do we get the other side? Because this one is a square root. We don't have two sides for this one. All right, we only have one because it has to be a function. So is this truthfully the inverse? And the answer is no. No, it is not the inverse. Not inverse yet. Because what we know is that if you look at this and think about it, the domain of f of x is the range of f prime of x. The range of f of x is the domain of its inverse. So when you see this, the domain of this function, domain of f, if we see right here, is we are starting at 8. And it's all values starting at 8 and going to infinity. Well, that means that this has to actually be the range of this function. So if we go over here, the range then should be starting at 8 going to infinity. And that's the y values. And if you notice here, it does do that. Since 8 goes to infinity both sides. Well, the range of this function actually starts at 0. All right, includes 0. Goes down to negative infinity. So actually, we should rewrite this as negative infinity to 0. All right, let me start with the lesser number first. All right, negative infinity to 0, because we are looking at the range starting at negative infinity and going to 0, and that's where we're seeing our range. Okay, well, if this is our range of our function, then according to what we talked about before, this right here then